the currents in the water change. They go crazy. Now imagine random points in that water suddenly turning into steam. And they're your supernovas throughout space.
Yeah.
We know space-time is curved. We don't know why it's curved. It's curved by the eddying of the water around it and the energy particles. Now, here's the kicker, and this is the bit that kept me up. If you are in one fixed point in any point in that drop of water, all those water molecules will be moving away from you due to planar effect. Because even if it's affecting you and you're in that plane and it's blowing you this way, your observation, because you're not feeling the solar radiation or this planar effect, all you're seeing is the distance increasing. Yeah?
Yeah.
You are only seeing an increasing distance. You're not seeing the eddies in the water at all.
Nope.
You're not seeing that you're the one that's being propelled. You're only seeing the distance increase, so you believe it's ever expanding. Now, if you look at it from a finite point of view, an amoeba would see every single point of steam shooting away from it. It might be propelled to the other side of the tank, but it's watching every other single point from it disappearing in the opposite direction.
Yes.
I believe time and space, there was no Big Bang. It's been a continual cascade, and you can trace it back to a hydrogen molecule breaking down, because when a hydrogen molecule originally breaks down, it creates muons and it creates quarks. Now, if it creates a muon and it creates a quark, which can both be simultaneously in the same place at the same time, independently of each other, because you've got quantum entanglement, then you're allowed a cascade failure. If you have a cascade failure of a quark, you have creation of matter. If you have creation of matter, you've just described a supernova. So because a quark can come into existence and disappear from existence and come into existence, as far as we can see, I believe a quark doesn't come into existence and disappear. That's what science tells you it will always do. I believe it's travelling in a straight line.
Right. Science is saying that that it's appearing only because we're observing it.
Yes. That's what I'm trying to say.
Yep.
But it believes, it appears...
So we're
a
assigning a Big Bang.
No. It believes it appears and it disappears. It appears, it disappears, because we're observing it. Now, tell me, if you stood on a fourth dimension, which is looking at the bowl of water, which we can't see the bowl of water. We're in the bowl of water. We're the amoeba watching everything move away from us because we cannot understand the fact that the explosions going on all around us are causing the water to swell.
Yep.
No, we're the fourth dimension and we're over here. And we're the amoeba looking down. Oh, I'm losing myself. Where was I? Oh, you interrupted me. Okay. Which bit was I explaining?
The force is moving away because we've expanded out.
Yep. So if you've expanded out, you can't see the swell in the water. You can't see the trajectories of all the planar explosions that are actually going off. As far as you're concerned, everything will be retreating at an ever-increasing speed, because every time there's a single explosion, the force on you it's added, it's multiplied. You might be going up in this sort of direction and flipping round, but because we're looking at it from such a finite, minute point of time, it doesn't matter how we look at it, it will always be going in the opposite direction from us. Space-time is curved. We wouldn't know whether we're going round in a curve at the time, because we're looking at it from such a microscopic slither. Everything looks stationary and it's only moving in one direction. Now, if everything looks stationary and it's only moving in one direction, we're going to believe in an expansionist universe. I don't believe it is an expansionist universe. I believe space, as we know it, is finite. Every single explosion causes us to be affected and every other particle to be affected. We're seeing things move away from each other because we're moving away from the relative event that propelled us. If we were the other side of the universe and it was a different propelling force, we'd see everything still moving away from us. because we're moving from that propellant force. Nothing's coming towards us unless it's been thrown towards us in a blast. Which brings me to, if there is another supernova and a pressure wave is coming towards us, would we see that universe coming closer, or would we simply see it colliding? Now, we've seen universes collide. If they were all moving away from us in straight lines, because that's the way a blast radius works, it moves in a straight line, universes wouldn't collide. Universes couldn't collide.
Do you mean galaxies?
Whole universes. We've got galaxies. We believe there's multiple universes.
Okay.
Okay? Now, if each galaxy has the ability to create supernova, which is planar forces, then that's just a star in an eddy into the current. It's just a superheated molecule in a drop of water. We're basically expanding. Our little universe can be seen to expand. It can be seen to contract. It can be seen to disappear. It doesn't matter. There's multiple universes, just like there's multiple galaxies.